Welcome back to my chemistry lessons. Today we are going to see what is galvanic cell. Example for galvanic cell is a Daniell cell, and see what is a galvanic cell. Galvanic cell or electrochemical cell is a device in which oxidation and reduction half-cell reactions are occurring, and the change or loss of chemical energy appears as a electrical energy. So in a electrochemical cell, chemical energy converted into electrical energy. So here you can see the example. There is a zinc rod dipped in zinc sulfate, a copper rod dipped in copper sulfate. So anode, an electrolyte, there is a separation of two electrolytes, and there is a cathode part, that's a cathode, then electrolyte. So when you see the diagram here, you can see there is two beakers. In one beaker, this part, a metal rod, a zinc rod dipped in zinc sulfate. Zinc sulfate is an electrolyte. And other side, a beaker containing copper sulfate, that's the electrolyte, aqueous solution of copper sulfate. And it has a metallic rod, copper. So what happens is when a zinc rod is dipped in zinc sulfate, the metallic zinc becomes zinc dipositive ions. So that is we call oxidation. And the other part, the copper dipositive ions from copper sulfate receives those electrons and becomes metallic copper. And the metallic copper deposit on the cathode. So here, copper dipositive ions receives two electrons and become copper. So that reaction is called reduction. So we call it as a reduction half-cell reaction. And the other side, the metallic zinc becomes zinc dipositive. That means oxidation number changes from 0 to +2. And there is a liberation or a release of electrons, and we call it as an oxidation. So in net cell reaction, if you add the reaction at anode and cathode all together, we'll get zinc, solid zinc plus copper dipositive from the solution gives zinc dipositive aqueous solution electrolyte plus metallic copper. So here what happens? The right-hand side, electrons on the right-hand side of the first equation cancelled with the electrons in the left-hand side of the second reaction. So the net reaction will be zinc plus copper dipositive gives zinc dipositive plus metallic copper. So that reaction altogether we called as redox reaction because the half part is oxidation, other part is reduction. So here, when you look into the diagram again, you can see there is a vented glass tube that's called salt bridge. It is filled with an electrolyte like potassium chloride. So here, when you look into the diagram, you can see the electrons are passing from anode to cathode. So when you back to the functions of galvanic cell, you can see, as you know, as we discussed earlier, we know that the cell consists of metallic zinc act as anode and metallic copper dipped in copper sulfate act as a cathode. So reactions we already seen, equations we already seen that, and here. There is another important thing we have to discuss is salt bridge. You know, salt bridge is a bended glass tube filled with electrolytes like potassium chloride. So what is the main function of the salt bridge? Why we are using the salt bridge? So the main function of salt bridge is to help to keep the electrical neutrality of the solutions without the mixing of two electrolytes. So that keeps always electrical neutrality. That means in some stage, as we conduct the reaction for more long time, there will be shortage of ions in both electrolyte. So in that stage, the salt bridge will able to provide cations and anions, and that way that keeps electrical neutrality of the electrolytes. And the other point is it also acts as a electrical connection between two half cells. So the one half cell means is called oxidation. See, oxidation half cell. That is zinc rod dipped in zinc sulfate. Another part is copper rod dipped in copper sulfate. So there are two half cells. So salt bridge keeps electrical neutrality between two electrolytes and also act as an electrical contact. So thank you for watching. All the best.